Welcome to qnawire.
So now we'll work on problem 90 from chapter 20. In this problem, we're asked first in part A, what is an electrolytic cell? So an electrolytic cell is similar to a voltaic cell. But the difference is that the electrolytic cell requires an external voltage to be applied. It is operating under it's operating a non-spontaneous reaction. So in order to drive the cell in a direction it does not want to go, we need to apply an external voltage. So if we had an EMF of a cell which was -2 or -0.2, and we wanted the cell to go that way versus going in the direction where it's +0.2, then we would need to apply a voltage to the cell to be able to get this reaction going. So in part B of this question, we're told that the negative terminal of a voltage source is connected to an electrode of an electrolytic cell. Is the electrode the anode or the cathode of the cell? Explain. So here, the question is which which electrode do we attach this terminal to be able to drive this reaction? So the negative terminal of a voltage source would refer to the side that has the flow of electrons going towards it. So we want the flow of electrons go to where the reduction is happening, which is at the cathode. So the negative terminal will be connected to the cathode. We need to provide the electron source to the area where reduction will occur. In part C, we're asked, the electrolysis of water is often done with a small amount of sulfuric acid added to the water. What is the role of the sulfuric acid? So here, we know that sulfuric acid is a strong acid, and so in water it will immediately ionize to the H plus and SO42 minus ions. So since water has a very poor conductivity, it cannot conduct electricity very well. It is necessary to add some ions, which will improve the conductivity of water, since the conducting electricity is necessary for an electrolytic cell to work. In part D, we're asked, why are active metals such as aluminum obtained by electrolysis using molten salt rather than aqueous solution? So typically to melt a salt, we need to go up to a very, very large temperature. So the question is, why don't we just use the salt in solution as opposed to going up to this high temperature? And the answer is that in an aqueous solution, the electricity, the electrical energy that's being provided would go towards the water. would go towards the electrolysis of the water as opposed to the electrolysis of the salt. Since the purpose of the electrolysis of a salt is to produce the elemental metal, we need to do this when it's not in the presence of water to be able to focus our energy on the metallic